In this work, we have developed a novel and flexible MWCNT PDM-based resistive force sensor. The force sensor was fabricated using screen printing and laser pattering process for detecting various of applied force. The sensor includes two parts. First, the electrode. The electrode for the force sensor was developed by depositing the silver ink on a flexible captain substrate using screen printing process. The screen printing process is a cheap and easy method with high quality. Also, the highly constructed active sensing layer of the force sensor was prepared using a laser machine. The honeycomb structured active sensing layer can reduce the average density of the sensor, which is able to have a more comparison with the same force. For comparison, we also made unstructured active sensing layer so that we can show that how many percent of the sensitivity can be increased compared with the honeycomb structure and unstructured active sensing layer. The capability of the printed sensor was investigated by the printed electrode and MWCNT PDMS. Is subject to its varying force range from 0 Newton to 20 Newton. At the left side, we can see this the fabrication step of the active sensing layer. It includes of the 6 steps. Initially, we put the MWCNT and the toluene solvent into the PDMS. After standing it for 24 hours, we put in the carrier engine, then doing the sonication and the mixing. After the composite become uniform, then we put it into the mold and carrier at 120 degrees for 20 minutes to get the conductive PDMS. The last step is we put the conductive PDM into the laser machine to cut the structured sensing layer and unstructured sensing layer. In the middle, we can see the force sensor configuration. It includes 5 layers. The first layer is captain, followed by the AJ800. After that is the active sensing layer, MWCNT PDMS. Then AJ800, and the last is the captain again. And we can see here is a photograph of the fully assembled force sensor. In the right side, we can see the AJ800 electrode roughness. It is only have 1.65 micrometer, and also in the figure B, we can see that the active sensing layer MWCNT PDMS, the roughness is only 0.43 micrometer. From the roughness, we can see that the active sensing layer and the electrode can be touched very well. The experiment setup was showing the left side. We can see the force sensor was first put into the compressed plate in the Mark 10 test stand, followed by connect the solder wire to the AJ LCR meter to detect the resistance. And the PC will connect with LCR meter, use USB and the lab view program during the post process. In the middle, we can see the dynamic response and the calibration curve of the structured force sensor and unstructured force sensor. From the calibration curve, we can see that the sensitivity of structured force sensor is 4 times higher than the unstructured force sensor. In the right side, we are showing that structured force sensor, when subject to a 4 Newton force for 100 cycles, it clearly showing that the force sensor has very high repeatability with almost no drift. As conclusion, there's 2 types of flexible resistance-based force sensor with honeycomb structure and unstructured active layer was fabricated using screen printing and laser pattering process. The force sensor with structured active layer has a sensitivity which is 4 times higher when compared to a force sensor with unstructured active layer. The structural force sensor is highly repeatable with almost no drift even after 100 cycle of the 4 Newton applied force. And for the further research, it includes optimize the force sensor performance by varying the ratio of active layer components. So that making the active sensing layer even more softer to get even higher sensitivity. Also, we need to study the impact of temperature and humidity variation on the sensor performance because maybe temperature and humidity will affect the sensor performance. That's all.